Water softening is the removal of calcium, magnesium, and certain other metal cations in hard water. The resulting soft water is more compatible with soap and extends the lifetime of plumbing. Water softening is usually achieved using lime softening or ion exchange resins. Problems with hard water. The presence of certain metal ions in water causes a variety of problems. These ions interfere with the action of soaps. They also lead to buildup of limescale, which can foul plumbing, and promote galvanic corrosion. In industrial-scale water softening plants, the effluent flow from the regeneration process can precipitate scale that can interfere with sewage systems. Soap scum. The slippery feeling experienced when using soap with soft water occurs because soaps tend to bind to fats in the surface layers of skin, making soap molecules difficult to remove by simple dilution. In contrast, in hard water areas the rinse water contains calcium or magnesium ions which form insoluble salts, effectively removing the residual soap from the skin by potentially leaving a coating of insoluble stearates on tub and shower surfaces, commonly called soap scum. Which of these effects is considered more or less desirable varies from person to person, and those who dislike the sliminess and difficulty of washing off soap caused by soft water may harden the water by adding chemicals such as baking soda, calcium chloride or magnesium sulfate. Water softening methods. The most common means for removing water hardness rely on ion exchange polymers or reverse osmosis. Other approaches include precipitation methods and sequestration by the addition of chelating agents. Devices which use magnetism or electrolysis as a water softening technique claim to inhibit scale buildup without actually removing hardness ions from the water. Such devices have been marketed to consumers since the early 20th century, but are fraudulent. Ion exchange resin devices. Conventional water softening appliances intended for household use depend on an ion exchange resin in which hardness ions mainly Ca2+ and Mg2+ are exchanged for sodium ions. As described by NSF/ANSI Standard 44, ion exchange devices reduce the hardness by replacing magnesium and calcium with sodium or potassium ions. Types of ion exchange materials. Ion exchange resins are organic polymers containing anionic functional groups to which the dications bind more strongly than monocations. Inorganic materials called zeolites also exhibit ion exchange properties. These minerals are widely used in laundry detergents. Resins are also available to remove carbonate, bicarbonate and sulfate ions which are absorbed and hydroxide ions released from the resin. Regeneration of ion exchange resins. When all the available Na+ ions have been replaced with calcium or magnesium ions, the resin must be recharged by eluting the Ca2+ and Mg2+ ions using a solution of sodium chloride or sodium hydroxide depending on the type of resin used. For anionic resins, regeneration typically uses a solution of sodium hydroxide or potassium hydroxide. The waste waters eluted from the ion exchange column containing the unwanted calcium and magnesium salts are typically discharged to the sewage system. Lime softening. Chelating agents. Chelators are used in chemical analysis, as water softeners, and are ingredients in many commercial products such as shampoos and food preservatives. Citric acid is used to soften water in soaps and laundry detergents. A commonly used synthetic chelator is ethylene-diaminotetracetic acid. Distillation and rainwater. Since Ca2+ and Mg2+ exist as non-volatile salts, they can be removed by distilling the water. Distillation is too expensive in most cases. Rainwater is soft because it is naturally distilled during the water cycle of evaporation, condensation and precipitation. Health effects. Effects of sodium. According to the Mayo Clinic, an 8-ounce glass of softened water generally contains less than 12.5 mg of sodium, which is well within the Food and Drug Administration's definition of very low sodium. Of course, the exact amount of sodium present in soft water will depend upon how much hardness is being removed by the softener as well as the levels of naturally occurring sodium that is present in many groundwater sources. The CDC recommends limiting daily total sodium intake to 2,300 mg per day, though the average American consumes 3,500 mg per day. because the amount of sodium present in drinking water even after softening does not represent a significant percentage of a person's daily sodium intake. The EPA considers sodium in drinking water to be unlikely to cause adverse health effects. For those who are on sodium-restricted diets, the use of a reverse osmosis system for drinking water and cooking water will remove sodium along with any other impurities which may be present. Potassium chloride can also be used as a regenerant instead of sodium chloride, although it is more costly. For people with impaired kidney function, however, elevated potassium levels can lead to complications such as cardiac arrhythmia. Hard water also conveys some benefits to health by reducing the solubility of potentially toxic metal ions such as lead and copper, which are more soluble in soft water than in hard water. See also: desalination, ion exchange, water purification. References. External links: Association of Water Technologies, Water Quality Association, Consumer's Guide to Water Softening, Drinking Water Inspectorate.